Hello and welcome back. Year 13 for the maths. Topic, limits and series expansions. This is actually not enrichment. This is quite a straightforward question. I only made it the other day, and it's probably a 3-star question using the usual starage, if you want, in using my booklets and in my papers. So it should be just pretty straightforward for someone who's exam standards. So the question is actually saying to evaluate this particular limit by using series expansion, standard series expansion. So what is the only obvious thing that is resembles an expansion is of course the log of 1 plus 1 over x. So we have an expansion for that. I'm going to write it up here. So this is in the formula booklet, I believe, in most boards. So the log of 1 plus x is x minus x squared over 2 plus x cubed over 3 minus x to the 4 over 4 plus higher order terms of at least x to the 5 or higher. And this particular expansion, we need to be aware that is valid. I think the validity is also given in the formula booklet. I think is valid between including 1 but not equal to -1. So, and the reason I'm writing that up there is because when we replace x for 1 over x, we want to make sure the expansion is still valid, so we're not doing silly things. So if we replace in here the log of 1 and I replace x for 1 over x, this will become, of course, 1 over x minus, I'm going to put there a half like this, and this is going to go minus a half x squared at the bottom plus the 3 at the bottom as a third, and of course flipping it is going to go to x cubed minus ... And this particular expansion, since the limit's actually positive, we're going to positive infinity. If x, I'm looking at this part here for the positive numbers if you want. So x is perhaps, we can put equal here, but when we flip it, of course, this will go, oops, I'm writing silly things. I should really write it, because this will become infinity. So if you want, we don't need to bother write it. So 1 over x is bigger or equal to 1 is okay. All right, so I'm not going to put, obviously, I should have written it, 1 over x, for example, is something like that, but it looks a bit silly. Okay, so we're going to use this particular expansion, so for that part of the limit in there, which I've got up here, and the rest is just purely processing the rest of the algebra, which is not that difficult. So the limit as x tends to infinity, x minus x squared, and I'm plugging now part of my expansion that I've got in there, which is 1 over x minus 1 over 2x squared plus 1 over 3x cubed. Can I put one more term? Maybe I will. Not that I need it, as you can see. Once I take the limit, of course, it's only one term that will make the difference there. I don't know if you can see which one it is. Let's do a little bit tidy. First of all, limit x tends to infinity. X minus, this produces another x, which will cancel. And then we got a plus x squared will cancel the x squared at the bottom to give us a half. And notice this term is independent of x, as x tends to infinity. But now, when I times the rest of the terms, I'm going to get minus now. 1 over 3 over x plus 1 over 4 over x squared minus, if you want, 1 over 5x cubed to continue the pattern, plus ... So we should be able to see what happens here. First of all, this x's, okay, will cancel, and this is now the rest that is remaining inside the argument of the limit, which we need to take limits as x tends to positive infinity. So as x gets very large and positive, all of these terms which have, of course, x in the denominator will cancel, not cancel if you want, they will vanish basically, they'll go to 0. So the only surviving term from this particular one is a half. And I think this is a fairly straightforward question. Apart from, of course, obtaining this expansion and just plugging things in, everything should work. Okay, I think this time all of us should be laughing.